a really big battery. So it's heavy and it's expensive. So part of our vision of 2030 as well is to make cars accessible, so that we can have a broad reach of society. And if you make cars that are so expensive, then that doesn't meet that goal. So it's about pushing ourselves to get to the next technology that can make the EVs more accessible, which means the right range, the right cost, the right balance, so that we can get to our 50%. So on the right you can see the future. The future is solid state batteries. This is the latest technology. So this is like a global research effort between Japan, other regions in the world, as well as our team in Silicon Valley, who are working with NASA using, they call it material informatics, to actually produce and create materials that don't exist today. And they're working on those now to be able to create the battery of the future. So they've made a lot of progress, and now they're into you start out at a single cell level, and you work at a pack level, and you get bigger and bigger. So this technology is coming. And so now we have kind of an image of what it's going to look like, and we call it a solid state battery. And this is a type where we'll have, like, we call it power density, so it means like a weight to power ratio, and we'll be able to have basically double the output of the same size battery, or half the size battery with the same output. And this is going to be, you can see the costs go down 65%, and this is going to make it more accessible. So that finally, and it charges faster, and it has double the range that we have now. So that basically we'll be able to take a car and you'll be able to have the same range. You could have the same range as a current ICE engine, gasoline engine, and you can go to the gas station or fill up the EV station, and you can get a charge in the same amount of time that you can to fill up a gas tank. So that's the goal. That's where we're heading. This is the type of research and advanced engineering that's going on every day. We've already talked about, by 2028, we have a vision of being able to get there. It's a challenge. It's not already existing. It's an everyday challenge for the company, and that's what we're working on. But in order to have your true vision, your 2030 vision of sustainability, and we mentioned the global warming issues, societal issues, we can't just think about ourselves, and ourselves means the car. We can't just design a car anymore. We have to design it as a system, as an ecosystem. And this is a new approach. And it's a bit of a chicken-egg problem. That means that we don't have enough batteries to create a sustainable system to work with the batteries when they're finished. So that's going to come over time. But the idea is we're going to create a system where we're going to try to keep the batteries going as an ecosystem all the way through their lives. And the first step is to try to reuse those batteries, then remanufacture them, then reconfigure them, then connect them to the grid, then try to get them recycled into the full ecosystem. So this is part of the things that we're working on now. Some more details coming. In order to do, one of the things to do that is more of a better connection to the grid, connection to the world. We say V2X, and it means X means kind of everything. So vehicle to home, vehicle to grid, and it's like vehicle to office, whatever it is. So we have all of these ideas that we're working on now, and the Leaf has bi-directional charging capability. So right now, all the projects that are out in the world use the Leaf as an experiment because it works really well to do that. But the idea is that, and we're going to talk a little bit more about that, about how it can be a part of your house, a part of your city, a part of your electric grid as well, to kind of balance the whole system. Then, while this video is playing, a little bit more. So we've created a kind of a company within our company. It's called 4R, about how we can actually manage this battery life cycle. And because currently, if a current, like an ICE engine, there's we have a scrap yard, right? The car gets in an accident, it goes to the junk yard, people buy the parts, that's what we have. But for batteries, nobody knows what to do with them. So we're in process now of creating this kind of, as I mentioned, this reuse, reconfigure, refabricate, recycle type system. So just the only important thing to see in this video, besides vacuuming and battery, is to look at what's inside of it. And so you'll see, as I mentioned, we have cells, we have packs, we have modules, and we have a whole bunch of them. It looks like a bunch of laptop batteries. So once you take out this battery, you're going to the cover, you're going to see it. But one thing Nissan is really proud of is I forget the total number, but it's like 3 billion miles or something like that we've driven, and we had no serious incidents in the road, accidents at all with our batteries. And so we're very proud of that. But you can see what's inside here. So you can imagine that the reality is we have to know the state of health of the battery itself, how it's doing. And then let's say we decide, like your cell phone needs to be, it's getting a little bit reduced. So why is that? So we're going to break apart the batteries. We're going to look and see, okay, maybe 70% of those modules are still going to be okay. So we're creating a system where we're going to take those modules out, we're going to rebuild a new battery. That's the best way to recycle, is to reuse. And then take the other modules that are lower capacity, and maybe put those in a separate unit to be a battery backup for your house, or for a business, or things like that. So these kind of business opportunities are ongoing. So we're working on that now, as far as the full ecosystem of the battery. And so, and then finally, when that actually has been used and it's even more further reduced, then finally it'll break down, recycle all the metal, recycle all the components that are in the battery, the lithium, the cobalt, the other things that are in there, and then that'll give us the full ecosystem. So that is really what I wanted to kind of go over with you today. So I want to connect our vision of 2030, what that means in a engineering R&D part of the world, how that relates, and we connect the Japan kind of technology engine to what we do in the regions, how we execute from what the customer sees, what the customer needs, the ecosystem is, how we deliver vehicles to the customer, how we set goals for the company, but those relate to the customer and how the customer embraces our technology and what we do as a company. So I think I want to move on to the rest of our presentations. I appreciate your patience in listening to my long technical explanation. I wanted to give you a flavor for what we do in the engineering side of the world and how that connects between Japan, the Americas, South America, and how we engage all the teams here. So with that, thank you very much for listening. And it was great to see you guys today. Enjoy yourself in the show today.